Okay, so today, like I said, we're talking about adding rational numbers. And again, when you see that term rational, you're thinking pretty much decimals, fractions. And then you can also have integers and whole numbers and all that. But we're going to first talk about adding with like signs. And there are two steps to adding with like signs, which hopefully can be pretty straightforward. Add the absolute values. And I do those little symbols there. Those are bars that go on the right and left of the number or numbers that you're dealing with. So that's what we're talking about with absolute value. And then step 2, just keep the same sign of both numbers. So mainly talking about two numbers, but we'll extend it out to more with adding like signs. So get that written down, and then we will look at a couple examples. And we're going to tie in what we did yesterday with estimation. So there's a reason why we estimate. It actually helps me to know if my answer to these problems in this lesson even make sense. Okay. What we're going to do is we're going to start off with one problem here. I'm going to move on. And if you don't have the notes, you can get it from somebody else. We're going to add these two numbers right here. So go ahead and write that problem down. And notice the verb that they give you, add. Okay, so you hopefully realize, oh, I should probably add. Now, these two numbers that are up here, the negative 2.3 and the negative 4.6, do they have the same sign? Yes. Yes. So what were those two steps? First, add the absolute values. And then second step, keep the sign of the two numbers in this case. What's the absolute value of negative 2.3? This is 2.3. What's the absolute value of negative 4.6? 4.6. And we're just adding those up. Go ahead and do that. Yes, ma'am?
Why would you keep the negative sign?
Well, we're still on step 1. We're just adding these two numbers together. Step 2 says keep the sign of both of them, so my answer is going to have that.
Okay.
All right, so 2.3 plus 4.6, 6.9. And then step 2 said keep the sign of both, which would be, I heard it, negative 6.9. That's my final answer. Now, yes, sir?
Whatever's a negative and one's positive.
Good. And that's the second part of the lesson. We're going to see, all right, what do we do if one's positive, for example, one's negative, or vice versa? Yeah, we'll deal with those. Let's just get down with the same sign, and then we'll go to that, definitely. Okay, now yesterday, do you guys remember we had to estimate by rounding? Okay. You're not doing this on all your problems, but some of them they're going to say estimate, then add. So you have to do an estimation, and then you actually have to add it like we did here. Okay, let's look at negative 2.3. What would negative 2.3 round to the nearest integer? Remember, integer. Well? Okay, negative 2. So I'm rounding this to negative 2. What would negative 4.6 round to the nearest integer, Joey? Negative 5. Okay, so what's negative 2 plus negative 5? Negative 7. Now look at my actual answer and my estimate. What do you guys think?
Accurate.
It's very accurate. And you can, listen, with your estimates, they're not going to be the same. They may be. Sometimes they do happen to be the same, but they may be a little bit off, or it may seem like they're really off, but they should be pretty close relatively. So you'll see some of them are going to be closer than others, but they should at least be reasonable. Okay, next one is, I don't need to do that. Next one is dealing with mixed numbers in this case, or mixed numbers and fractions. So here it says find the sum. So what is it asking you to do? Add. That's all it's asking for. Mr. What does find the sum? Well, what does sum mean? The answer to an addition problem. So what's the answer to this addition problem? Okay, do we have the same sign for 1 7/8 and 2 3/4? Do they have the same sign?
Yes.
Yeah, they're both positive sign. And I mean positive or negative. So do they have the same sign? Yeah, they're both positives. So we just add the absolute values and keep the same sign. Yes, sir. Tucker? Oh, okay. Hold on the answer. Sorry. Okay, what's the absolute value of 1 7/8? 1 7/8. What's the absolute value of 2 3/4? 2 3/4. So what I'm going to do is I'm going to add those two together, and then my answer is going to have to be positive or negative. Positive, because they're both positive. So that I hope makes sense. Can you add these just the way they are? No, and this is going back a couple lessons with that LCM, LCD. Do we have common denominators? So what would be the common denominator?
You would have to multiply 2 3/4 times 2 over 2.
Good. I'm going to multiply this fraction by 2 over 2, which is really just a big fat 1. So am I changing the identity of this fraction? No, I'm just renaming it. Have you guys heard of that term, rename? Just calling it something else. Yes.
So like for step 1 you said add the absolute values.
Right here.
So what do you mean by like when you have the bars on the side?
Oh, that's just absolute value. If you forget what that means, it's like having those bars. So it's like saying, what is the absolute value of 1 7/8? So, okay. Renaming is kind of interesting. Okay, you guys call me Mr. A. Some people call me Mr. Alcocer. And get this. There are 2 people right now, 3 coming up, that call me Dad. So, Dad, in their case, Mr. A, in some of your cases, or Mr. A and others, they're all different names. But are they referring to the same person? Yes, in those cases they are. So, that's just renaming. So, what is 3/4 renamed to? 2 6/8. And I did not change the value, I just changed the name. Okay, so now, bless you, 7/8 I don't have to change. I just want to line it up for myself. You don't have to do that. But what's 7/8 plus 6/8? 13/8. Okay, and then what's the whole number parts? 1 plus 2? 3. So I get 3 and 13/8. Is that proper?
No.
Why not? Why is it not proper? It looks good. We added it, right? Tucker?
Because there's an improper fraction and you have to change that.
Yeah, you don't want a mixed number with an improper fraction in it. So 13/8, this is just like kind of my thought bubble. This is what I'm thinking. What is 13/8 simplified? Wilson? 1 5/8. So you got the numbers right. It's 8 goes into 13 once with the remainder of 5, and you keep that same denominator. Okay.
So you just divide it?
Yep, just divide it. Got that mixed number. So what is 3 and 13/8? It's the same thing as 3 and 1 5/8, which would give me 4 and 5/8. Now, did we talk about this earlier? 3 and 13/8 is actually an addition problem. Did we talk about that? Okay, we may have not taught. It might have been in another class. But these two are being added. And are these two being added? 3 and 1 5/8? Yeah, that's how we get the 4 and 5/8. So that's my answer. Okay, but is it accurate? Like, does it make sense? Maybe all this process was like, wow, it looked really good, but doesn't make sense. What's 1 and 7/8 rounded?
2.
Yep, Will?
2.
2. What is 2 and 3/4 rounded? Jack?
2 and 3/4
Yep.
rounded would be 3.
3. All right, what's 2 plus 3? Oh, look at this. What do you guys think?
Accurate.
It's very accurate. It's 3/8 off, so it's very close. Not even 1 off. It's 3/8 off.
You always have to check it like that?
Some problems are going to say estimate, then find the sum. So you're going to have to estimate and then find the sum. So some are just going to say find the sum. You can just go ahead and do that. But others are going to say do both. And so you'll have to do both. All right, you guys good on this? Pretty comfortable? Okay, on the bottom of page 15, I believe, I want you guys to work out number 6. Number 6. And I'm going to call one of you to come up here and work it on the board the way I worked it out. So don't do it like, oh, I just did mentally, so here's the answer. You're going to show us what you did, and you got to show us the right way. Are you wanting to do it, Ryder?
I have a question.
Yeah, go ahead.
What page was it for?
Bottom page 15, number 6. So it should be that problem right there. Are these volunteers?
Yes.
All right, Justin. When you're done, you can come up, or if you want to come up now, that's fine. But you can come up when you're ready, and then hopefully you guys did a similar process. All right, I'll have Justin do the actual problem, and then I will have Cam do the estimation part. So you're going to have to round numbers. And then I'll possibly get some others of you to work out these problems. So yeah, when you're ready, come on up.
Wait, are we supposed to estimate and answer them?
Do the actual problem, and if you have time, just estimate real quick. Yeah, you just use either one of those.
Well, we have to find the absolute value of these. So the absolute value of that is 1.73.
Good.
And the absolute value of that is 1.15.
Good. So they're both positive absolute values.
So you add them up.
Mm-hmm. And as you're adding it up, I'm just going to talk a little bit. When you're adding or subtracting decimals, what do you have to make sure of?
Remember the sign?
Okay, yeah, remember adding or subtracting, but what, like, about the decimals themselves do you have to keep track of? Line up place value, right? Line up decimals. And, so Justin, you got the sum right here, and then what do you have to do with that? There's second step. So you added the absolute values, and second step, keep the sign of, there you go. So how many of you got negative 2.88? Or negative 2 and 88 hundredths? Okay, Cam, I don't know if that answer makes sense. So Cam, round those numbers, and then see if this makes sense for us.
So
Yeah, it's very set. Like anything that touches will be. And actually, let me do this, Cam. I'm sorry. There you go. Yeah, I'm not allowed to wear sleeves because it will mark up everything, so I understand that. Good. You're rounding that to negative 2 and that one to negative 1, and we're adding them. So what is negative 2 plus negative 1? Negative 3. Thank you very much. Is this accurate? Yeah. Okay, good. Good job, boys. You did very well. Okay. I need 2 more volunteers. They're going to work out a tougher problem, though. So I need those who are going to really buckle down, make sure they show us what's going on. All right, I'll get... Oh, you're okay. Joey wants to do the estimation, and then I'll go with Emma. You're going to do the actual. So work it out first. Get comfortable with it. It's actually number 8. Same section at the very bottom, number 8, which is that problem right there, number 8. Now, number 8 has 2 mixed numbers and a decimal number. And we haven't talked about this. See if you can try to figure it out. Emma will do the actual. Do you want to come up, Joey, and just do the estimate? If you're ready for it? Oh, he's ready for it.
Oh, yeah, Joey.
Okay, so round each number, add those rounded numbers, and see what we get. And hopefully Emma gets something close to that.
Not as near as integer.
Integer, yep. That's probably the easiest. That was a tough one. 2. Good. Okay. That's a decimal. You can't do that. Oh, okay. I guess you can. And then you're adding them together to get an estimate. Okay. And then just put the plus signs by them. By these numbers. Yeah, just so we know what happened. Okay. All right. Thank you very much. Yeah, just stick it right there. Boom. Gets it. Sorry? You can turn them all into decimals. You can turn them all into fractions. But you got to get the same answer, whatever it is. You may get a different name. But I would say probably the easiest is just to turn this into a fraction. But that's my way. You could also do it turning them into decimals. Fine. Emma, what did you do? Did you make them fractions or decimals?
Fractions.
Okay, come on up.
Should I take them?
You can take it, yep, to look at your work. Now, do these numbers all have the same sign?
No. Well, yes. Yeah,
They're all yeah, when I ask for sign, that means are they all positives or are they all negatives? In this case, yes, they are all positives. That's okay. We'll keep going. So all I have to do in this problem, just take it one step at a time. I'm going to add those 2 mixed numbers and then see what I get with that. All right, and then we got that 0.7. Okay, so she's renaming second Mixed number does not have to be renamed, and neither does the third number. The third number is 7/10, so you just write it as a fraction. All right, so here we have some addition going on. So right now she's adding all the fractional parts. And then she'll get a sum with that. Oh my. It's weird. Wait, 20/10? Huh. Interesting. Okay. And then, let's see what she does. I'm just commentating. I'm a commentator. It's like a ball game. And she combines the two together. She gets 5 20/10. But that actually equals a big fat 7. All right, listen carefully so we can move on so you can kind of know what happened. All right. She just rewrote the problem right here. And then right here, she renamed the fractions so that they all have a common denominator. And then here, she's showing me she did 6/10 plus 7/10 plus another 7/10, which would give you 20/10. Yeah, and then she divided that. She would have gotten 2. And then she added the whole number parts, 1 plus 4 plus 0, which is 5. And then what's 5 plus 2? 7.
Wait, what?
Okay. I can explain later, but question, yes.
Oh, so I transferred all of them into decimal.
Okay.
But what I got when I estimated, like I got 1.6 plus 4.7 plus 0.7.
So 1.6 plus 4.7 plus 0.7,
And I got the answer for 7, but then
awesome.
I estimated 1.6 and I got 2, 4.7, then I got 5, and 0.7, and I got 7.7.
Oh, okay. So this number right here, when you rounded it, you rounded to 7.7, but it's really close to just 1. Yeah. So that throws it off. Okay. That's all right. Okay, you guys at least fairly comfortable with adding like signs? Okay, yes. Possibly, yes. Just be ready for it. All right. Next, go ahead and take this down here. We're adding with unlike signs. So this is going to help you when you work it, hopefully on your own. If you forgot everything we talked about, at least you have the 2 rules. When we're adding unlike signs, that means adding positives and negatives, or negatives and positives. Yes, yeah, we're going to have both types of problems.
We need to write that
Yeah, write it down. And I try to make it as concise as I could. Like, I know it seems like a lot of words, but you really can't put it any simpler than that properly or accurately. You could say things, but they won't actually capture what you're trying to convey. So here, subtract the lesser from the greater absolute value. That's step number 1. And then step number 2, keep the sign of the larger absolute value. So you think we need to understand absolute value to add and subtract? Yes. And so not tomorrow, unless you want to come. Monday, yeah, you guys will have fun tomorrow. But Monday, we're going to talk about 1-8, subtracting rational numbers, and we'll get more into that. All right, so please write this down, and then we'll go to our first problem. What was your question on that last one? Do you remember?
Just how did how she, I think she was confused on
When I didn't get how you divided it, and then...
So she had 20 over 10. So what's 20 divided by 10?
How many times can 10 go into 20?
20.
So twice.
Right?
Mhm.
Yeah, I'll have to do that.
That's right. And so that's how she got that 2. And then she added the whole number of parts, got 5. So she had 5 plus 2.
I don't understand because you had 5 and 2 tenths.
So she had 5 and 20/10.
And then you divided
20 by 10 and got that 2. All right. Are you guys good with that? Let's move on. First problem. We're going to add 7 and 4/10 with negative 3 and 9/100ths. All right, boys?
Sure.
Sorry, I'm getting distracted. I'll put it back later, but yeah, just leave a little bit of space. I'll definitely mark it up. Okay, so here we ask, are we adding numbers with unlike signs? That means is one positive, one negative?
Yes.
Okay, so what we're going to do is this. We're going to look at these two numbers, and we're going to take the absolute values. We're going to do the bigger absolute value minus the smaller absolute value. Which one of these numbers has the bigger absolute value? So we're going to do 7.4. Therefore, negative 3.09 has the lesser. We're going to subtract it. Don't forget to line up decimal places. And this time we're subtracting. Last time we were adding.
Can we add a 0 over the 9?
Yes, you may. That actually helps you out for some of you to put your place value. Okay, so you're subtracting. Now make sure you subtract properly. And I get 4.31. But that was just step number 1. We just subtracted the 2. Which sign should I keep? The sign of the larger absolute value. Which one had the larger absolute value, Will?
Positive 7.4.
So we're going to keep it positive. Now I put positive. You don't have to put positive sign. If you don't, I assume it's positive. But I'm emphasizing it's positive.
It's not that hard. It seems way harder.
Yeah, and the thing is, as you keep doing this, some of you are already very comfortable with it. But as you keep doing it, you'll be like, Mister, I just do this naturally. And it takes time. It's not always... Yes, sir?
Do you always have to subtract?
If you have opposite signs being added, yes.
Okay. And it doesn't matter which order you're adding, you always put the bigger number on top.
Exactly. Now, great question. Listen very carefully, guys. If I were to switch this problem to negative 3 I'll just say it the right way, 3 9/100ths and adding 7.4, do not put 3 9/100ths up top and 7 4/10ths on the bottom. You cannot subtract that like this with this method. You're going to get some weird number. You're going to work it out. Looks good, but it's not right. How do I know if it looks good or not? The estimation. Yes, ma'am?
So how did you get like positive 3.4?
Because which one of these numbers has a greater absolute value? 7.4 or negative 3.09?
I don't know.
Okay, yeah, it's 7.4. It's the bigger number. Which one's the bigger number, 7.4 or 3.09? And so we keep it positive. Okay, what does 7.4 round to? 7. What does negative 3.09 round to?
3. Wait.
4.
Negative 3.10.
Negative 3.
Negative 3. And negative 3 and positive 3 are not the same. All right, what's 7 plus negative 3? 4. What do you guys think?
That's really close.
Okay, some problems are going to ask you to do estimation and add or just add. So if you have to estimate and add, you need to give me both. If they just say to add, you can just give me that, but that helps me out. Okay, next one. We're going to find the sum of negative 3 2/3 and 1 4/5. This one's a little bit tougher, guys, so I need you to listen up because we're going to do something we do with decimals a lot, but we don't really think of it with fractions. I need you to understand that fractions and decimals are almost the same thing. Now, yes, Ryder, they are not the exact same. It's not like you just treat them exactly the same way, but can fractions be written as decimals?
Yes.
Can decimals be written as fractions?
Yes.
Okay, you can kind of interchange them, so let's see how that works on this problem. Okay, are we adding two numbers with unlike signs?
Yes.
So what we're going to do is we're going to take the greater absolute value, which would be what?
3 negative.
The greater absolute value would be 3 2/3. And what's the lesser absolute value? 1 4/5. And we're going to subtract them. You cannot switch these around. There has to be this number minus that number. You can't switch them around. You get a wrong answer. Mm-hmm.
How is it less, or like, how is 1 over,
1 4/5.
sorry, over, I mean like, lesser than, like,
Absolute value. So if I did this, what's this value? And then what's that? So now we know, oh, this number is going to be bigger than what that number would be. So that's why I have to keep throwing absolute value out there. Okay, what's the common denominator here? Daniel, what do you think the common denominator is? 15. So I'm going to multiply both these fractions by 1 in the form of 5 over 5. Justin, please see me after class. 5 over 5 and 3 over 3. Okay? So here what we want to do is when we multiply them, we'll get those common denominators. So what's 2/3 times 5/5? 10/15. And what's 4/5 times 3/3? 12/15. Okay, now listen very carefully. 10/15 minus 12/15, you don't have enough to take away 12/15. So you have to borrow. And for a lot of people, for some reason, this could be tough, but we're doing this like normal decimal problems. Okay, I cannot subtract 12 from 10/15. Okay, so I'm going to borrow from the 3, make it a 2. Now, when I borrowed a 1 from here, I borrowed it in the form of 15 over 15. So I'm going to add 15 over 15. You're like, wait, Mr. I thought you said 1. Why are you putting 15? No. I didn't add 15. I added 15 over 15, which is actually 1. Okay, so this 1 that got taken away from the 3, it's right here. This is 1. And what does that give me? 10/15 plus 15/15? 25/15. Okay, so hopefully you get that. If not, it's okay. I'll give you another chance in just a moment. What's 25/15 minus 12/15? 13/15. And that's 2 minus 1? 1. Is this a positive or negative answer?
Negative.
Wait.
Positive. Negative.
Okay. Step 2. Which one of these had the larger absolute value? This number, so you keep a negative sign here. It's negative 1 and 13/15. Yes, sir?
Why did you take out 3?
This right here?
Yeah.
I just borrowed 1, and then this is the 1 to borrow, because you can't do 10/15 minus 12/15.
Wait.
And that's okay. If that's fully not there, that's all right. All right, I want to estimate, though, the original problem.
Is it 2 and 12/15?
Oh, negative 1 and 13/15.
But how could you have
Maybe circle that, and I'll have to come after. I'll give you some chance. All right, what's negative 3 and 2/3 round to the nearest integer? Yep, Finn. Negative 4. What does 1 and 4/5 round to the nearest integer? Nelson, what do you think? 1 and 4/5. 2. What's negative 4 plus 2? Negative 2. What do you think? It's very close. If you got some other numbers, like if you switch things around, you're going to find out that they're not very close, and that helps you realize maybe I did something wrong. Maybe I switched the numbers, maybe I didn't keep the sign. What if I got positive 1 and 13/15? Would that kind of tell me that I'm off? Yeah, so use that when they make you do it. If not, you can do it on your own. Okay, last problem I'll have you do, and I need 2 volunteers. I need them to show me properly how to do this. Someone's going to give me the estimate. Someone's going to give me the actual. Paul, give me the estimate when you're ready, and then the actual will be, I think, Will, you asked for it. So when you're ready, I would work it out, make sure you get it, and then you can come up and do it. And Paul, same thing. When you're ready, come up, you can do it. So get me the actual, and if you have a chance, get me the estimate. See if they match up. See if you match up with them. This is, if you want to know what problem it is, on page 15, very bottom, number 1. This is number 1, the first example they give you. Okay. And I'll have the estimate over here, if you don't mind. Thank you. Yeah, it's super picky. Yeah, click on that. There you go. Circle it. Boom. Let me do this, Paul, real quick. So it's easy. And if you want to bring your work, you can, or if you just want to do it up there, fine. Some people find it helpful to do it. Okay, so he's giving me a rounded. And Will, you can actually start working right here if you want. Just don't run into each other in your work. It's hard, right? See, it's tough to write on this board. It's not always easy.
It's easy for me. Use your fingers.
It must be me.
This is like so clumped together.
All right, thank you, Paul. I'll take that.
-6.
Okay, listen careful. Let's look at the estimate first. -9 5/16 rounds to -9. Does that sound about right? 3 3/8 goes to 3. All right, -9 plus 3 is -6. We're good with that. That's a good estimate. Okay, here we have the two numbers. We have 9 5/16 subtracting 3 6/16. He renamed it. And then can you do 5 minus 6? So he borrowed, and so I'm trying to interpret this. I wish I could make it bigger. Not that it's just harder to see. If you borrow from the 9, you make it an 8. And I added 16 sixteenths to make it 21 sixteenths. And then you can subtract, what's 21 minus 6? 15 sixteenths. And then what's 8 minus 3? 5. And then is it positive or negative? Negative. All right, let's look at this. What do you guys think of that?
Oh, yeah, that's accurate.
Yeah, they're accurate. They're pretty close. How many of you got that? -5 and 15 sixteenths?
What did you do to carry negative borrow?
You borrow from the whole number, 8. He added 16 sixteenths to 5 sixteenths. Because what's 16 sixteenths?
1.
Yeah, so you add 1, but you got 21 sixteenths. Yep. Because what's 5 sixteenths plus 16 sixteenths? 21 sixteenths. If you need to write that down, I would write it down, because sometimes it's hard to keep in our heads. Okay, your homework. 2 to 28 even, and then number 40. I'll get you the page in just a moment.
Wait, can you go back to that?
Yes, let me just get them started. Yes. Goodbye, Swivel.